Hi, folks. We're going to take a look at number 20 from page 75. So here they're asking us to determine the equation of both lines that are tangent to y equals x squared and that pass through the point 1, -3. So they actually gave us a pretty big hint here by telling us that there were two lines that do this. Certainly you could be asked this question, may not even know how many lines might satisfy these conditions. So I'm going to do is I'm going to draw a graph to see if I can get a sense of what's going on. Okay, so let's draw y equals x squared. And let's draw the point 1, -3. So say that's 1, so -3 somewhere here. And so what we're looking for is a point that's tangent to this curve and passes through 1, -3. So I can see that, makes sense that I can draw a line that looks something like this, which is tangent to the curve and passes through 1, -3. Then when you think about it, there might be another line that passes somewhere there. That's again tangent to the curve but passes through 1, -3. And I can't really see how I would be able to draw any other scenarios like this. All right, so this is our starting point, and we have to somehow find a way to determine the equations of these lines. Now, what do we need to determine the equation line? Well, we need a slope and we need a point. Well, we've got a point, so we need a slope. Unfortunately, we only know one point on the line. We know that these tangents are also going to pass through points on the curve. We just don't know what those points are. So since we don't know what they are, let's give them a name. So I'm just going to use one as a representative. Okay, and since I don't know that point, I'll call that point x, y. Okay, and I know that, the fact that it's tangent to this curve, it means that the um, derivative of the function at x is going to be the slope of this line. All right. So I think this is going to be my strategy to get there is I'm going to work with the slope formula. But if I take the slope of this curve, so, I take dy dx, okay, is equal to, well, the derivative of x squared is just equal to 2x. And obviously that doesn't give me enough information because I still have a variable in there. I have no idea where I'm taking the derivative. So I also know that the slope of this line can be determined by using the slope formula. Okay, so another way to determine the exact same value is to use the slope, which is y2 minus y1. So I'll do y minus -3. So y minus -3 over x minus 1. Okay. Now remember that x and y represent a point on the curve. And this is this is sort of the real important step here, is to realize that since this point is on the curve, I know that y is given by x squared. Whatever this x value is, the y value is given by x squared because this represents a point on this curve. And so that means I can rewrite this slope formula as x squared, minus -3, so plus 3 over x minus 1. All right, so let's see what that takes us. Is I now have two expressions that represent the same thing. This expression here represents the slope of the curve at x, okay, which again is the slope of the tangent line to the curve. And this expression here also represents that line, which is tangent to the curve and passes through 1, -3. So what do? We're just going to equate these two expressions. So we have 2x is equal to x squared plus 3 over x minus 1. And hey, look what we've got, an equation that we can solve. Okay, in fact, it's just fairly simple rational equation. So I'll multiply x minus 1 to both sides. So on the left, I'm going to have 2x squared minus 2x equals x squared plus 3. Okay, again, turned it into a nice simple quadratic equation. So I'll bring everything to the left side. So 2x squared minus x squared is x squared. Here I've got my minus 2x, and this is going to become minus 3 equals 0. And even better, this factors pretty nicely. So it's going to be x minus 3 and x plus 1. Okay, so that means the x values. And by the way, we should mention here that because we're working on the quadratic, it now makes sense that we might get two answers. So here we have that x is either equal to 3 or -1. Okay, and that even makes sense when I look at my diagram. It looked as though one of the values would be to the left of the y-axis and the other one would be to the right of the y-axis. So this fits what I kind of anticipated in my diagram. All right. We're not finished though, because they're not just asking us at which x values are these tangents going to occur. They're asking us to determine the equations of these lines. Okay, and of course, to determine the equation of a line, we need a slope and a point. So let's start with the point. Well, I don't have the equation of the tangent line yet, but I do know that the tangent line and the curve share this point. So if x is equal to 3, I can calculate the y value and I get a point on the line. And I can also use that x value to calculate the derivative at that point, or the slope of the tangent at that point using the derivative. And then I can do the same thing for x equals -1. Okay, so I'll split this up into two parts. So first I'll do x equals 3. Okay, so when x equals 3, y is equal to, well, I've just put it inside the function. Remember, the function is just x squared. So y is equal to 9, and the slope is just going to be given by the derivative. So 2 times 3 is 6. So we'll stick everything to y equals mx plus b. So y is 9, m is 6, x is 3, plus b. So b is just equal to 9 minus 18 is -9. So one of our lines will be y equals 6x minus 9. All right, now let's do the same thing for x equals -1. Okay, so when x is equal to -1, again, it's on the curve. So -1 squared is just going to be equal to 1 for our y value. The slope, again, is just going to be given by the derivative. So 2 times -1 is -2, and I can stick all of this into y equals mx plus b. So y equals 1 is equal to the slope, -2 times the x value, -1 plus b. So here we have, this is -2 times -1 is +2. So 1 minus 2 is -1. And so our other answer is y is equal to -2x minus 1. Okay, and there are the two equations for our lines. Okay, so a few steps here, but let's go back to see what sort of helped us create this equation that we could solve. So step number 1, not a bad idea when you've got something geometric to work with to draw an equation. Okay, we realized that the information that we had to determine the equation line was pretty minimal. We knew it contained this point, but we also knew it had to contain a point on the curve. And so we used the fact that there was two ways to determine the slope of this line. One was to use the derivative, okay, and the other was to use the slope formula with the point on the curve, which was an unknown, and the point that was given. And from there, we knew that the slope given by the slope formula needed to be the exact same as the slope that's given by the derivative formula. And from there, we were able to solve for the x values. And once we had the x values, we could plug them into the function, and we could plug them into the derivative formula to find the y value and the slope value. And then from there, find the equation of lines. Okay, that's it for this one.